Before going to explain about hydrogen bond, I would like to ask you a question now. Why orthonitrophenol exhibits intramolecular hydrogen bond and orthophosphoric acid exhibits intermolecular hydrogen bond? Before know about this answer, I am going to explain about hydrogen bond. So what is hydrogen bond? Hydrogen bond is defined as it is an electrostatic force of attraction between positively charged hydrogen and high electronegative atoms such as oxygen, nitrogen, fluorine is called hydrogen bond. Here, whenever hydrogen is coming close to high electronegative atoms such as oxygen, nitrogen and fluorine, an electrostatic interaction will develop. That interaction is said to be hydrogen bond. That interaction is hydrogen bond. Hydrogen bond is also formed rarely with chlorine atom. Hydrogen bond can be represented with dotted line or line wise. We can represent in both the ways. The bond distance is 1.79 angstroms to 2.25 angstroms. How much energy is needed to break hydrogen bond? In order to break hydrogen bond, it requires 2 to 10 kilocalorie per mole. 2 to 10 kilocalorie per mole energy is required to break hydrogen bond. In kilojoule, say 20 to 50 kilojoule per mole energy is required to break hydrogen bond. You know, hydrogen bond is weaker than covalent bond and stronger than van der Waals force of interaction. Hydrogen bond is weaker than covalent bond and stronger than van der Waals forces. Van der Waals force of interaction. It is the order of force of interaction. So, what is hydrogen bond? Hydrogen bond is a electrostatic force of attraction between positively charged hydrogen in polar molecule with highly electronegative atoms such as nitrogen, oxygen, fluorine, rarely with chlorine. It is hydrogen bond. Hydrogen bond is how many types? Next question. Hydrogen bond is of two types, intramolecular hydrogen bond and intermolecular hydrogen bond. We will discuss one by one. The first one is intramolecular hydrogen bond. Intramolecular hydrogen bond. What is it? Intramolecular hydrogen bond. This hydrogen bond present in same molecule. The hydrogen bond which is present within the molecule is called intramolecular hydrogen bond. For example, we are taking orthonitrophenol. Orthonitrophenol. So, phenol means you know hydroxybenzene. It is phenol. It is ortho position, meta position and it is para position. In a mono-substituted benzenes, 2 ortho positions, 2 meta positions, 1 para position is present. Whenever oxygen is coming closer to hydrogen, here hydrogen bond will exist in between these two atoms. This hydrogen bond is formed within the molecule, hence it is called as intramolecular hydrogen bond. Orthonitrophenol is also called as a steam volatile. Steam volatile. And second example I am taking orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde, commonly called as salicylaldehyde. What is the common other name of orthohydroxybenzaldehyde? Salicylaldehyde. It is a product which is formed in Remer-Tiemann reaction. It is orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde. It is benzaldehyde, you know. Ortho position. In ortho position, hydroxy group is present. OH group is present. It is a hydrogen bond which is formed within the molecule, hence it is called intramolecular hydrogen bond. Because of intramolecular hydrogen bond, there is a ring formation takes place. Because ring formation takes place in intramolecular hydrogen bond, it is also called as chelation. It is also called as chelation. So chelation is nothing but intramolecular hydrogen bond. And I'll take another example now. Orthohydroxybenzoic acid. Third example is orthohydroxybenzoic acid. Benzoic acid. See, in orthohydroxybenzoic acid, I'm writing here. It is orthohydroxybenzoic acid. It is also called as salicylic acid. Salicylic acid. In organic chemistry, salicylic acid is coal-based product. Whenever phenol is reacted with carbon dioxide in presence of an alkali, salicylic acid is formed. Okay, here hydrogen bond is formed within the molecule. Hence, chelation happens. It is also an example for intramolecular hydrogen bond. And another example, orthonitrophenol, orthohydroxybenzaldehyde, orthohydroxybenzoic acid, and chloral hydrate. The other example is chloral hydrate. Chloral hydrate. See, it is chloral hydrate, Cl. It is the structure of chloral hydrate. In chloral hydrate also, intramolecular hydrogen bond is present. Generally, ortho-substituted aromatic compounds are showing intramolecular hydrogen bonding, but it is not an aromatic compound, but it shows chelation or intramolecular hydrogen bond. So this is about intramolecular hydrogen bond. Generally, these are less water soluble. These are having less boiling point because hydrogen bond is present within the molecule. Now we go for intermolecular hydrogen bond. Second one, intermolecular hydrogen bond. So before going to start intermolecular hydrogen bond, I will repeat intramolecular hydrogen bond examples. Orthonitrophenol, orthonitroaniline also. Orthonitroaniline also exhibit intramolecular hydrogen bond. Okay, now intermolecular hydrogen bond. The hydrogen bond which is formed in between the molecules. In between the molecules. It is what? Intermolecular hydrogen bond. Example. Generally, hydrogen fluoride. When hydrogen fluoride molecule, when one hydrogen fluoride molecule comes closer to another hydrogen fluoride molecule, there will be hydrogen bond develops. Because this hydrogen bond is in between the molecules, it is called intermolecular hydrogen bond. Examples which are showing intermolecular hydrogen bond are HF, ammonia, H2O, formic acid, acetic acid, and alcohols, nucleic acids. What are nucleic acids? DNA and RNA. In DNA also, hydrogen bonds are present, which are connecting the two helix in formic acid and acetic acid. In formic acid and in acetic acid, due to the presence of intermolecular hydrogen bond, they exist as dimers. For example, I am taking acetic acid. See, this is the one molecule of acetic acid. When other molecule of acetic acid comes closer to this, hydrogen bond will be formed in between two acetic acid molecules. Then his dimer of acetic acid is formed. and I'm going to mix this concept with the colligative properties. Want half factor for acetic acid is less than 1. Want half factor is less than 1 for acetic acid. When? Because acetic acid is associative. Two acetic acid molecules can form a single molecule. Hence, number of ions or number of molecules before association, after association by number of molecules before association is the want half factor. So, before association they are 2. After association it becomes 1. I is equal. So, after association it becomes 1. Before association these are 2. So, 0.5 less than 1, want half factor. Okay, these are the examples for intermolecular hydrogen bond. In addition to these, some more examples are also there. They are para-nitrophenol, para-nitrophenol, para-hydroxybenzaldehyde, para-hydroxybenzaldehyde, and para-hydroxybenzoic acid. Benzoic acid. So I will take one example, orthonitrophenol. Instead of orthonitrophenol, we are taking para-nitrophenol. See, in para-nitrophenol, intermolecular hydrogen bond is present. How it will be? Within the molecule, hydrogen bond does not exist. It is due to the fact that hydrogen is far away from oxygen. There is a large distance. Hence, it cannot be able to form hydrogen bond within the molecule. Hence, it can form hydrogen bond with the nearby para-nitrophenol. So, it is para-nitrophenol. In the same way, para-hydroxybenzaldehyde and para-hydroxybenzoic acid also intermolecular hydrogen bond is present. And generally, the compounds which are exhibiting intermolecular hydrogen bonding, they are having high boiling point. High boiling point. So, para greater than ortho boiling point. Why? The exact question is why para-nitrophenol has more boiling point than that of orthonitrophenol. It is due to the fact that in para-nitrophenol, intermolecular hydrogen bond is present, whereas in the case of orthonitrophenol, intermolecular hydrogen bond is present. Less amount of energy is needed to break intramolecular hydrogen bond because it is present within the molecule, whereas in para-nitrophenol, huge amount or more amount of energy is required to break all the bonds in between or among the molecules. Hence, boiling point of para-nitrophenol is more than that of orthonitrophenol. And I am coming to the first question. Understand the first question. What is the first question? Orthonitrophenol is having intramolecular hydrogen bond, whereas orthophosphoric acid is intermolecular hydrogen bond. See, it is orthonitrophenol. Orthonitrophenol. Orthonitrophenol and orthophosphoric acid. I am writing. These two molecules are quite different. So, it is an ortho compound which is an aromatic, and in this aromatic compound, hydrogen, positively charged hydrogen is very closer to oxygen. But here it is not an aromatic compound. There are no ortho-meta para positions. Hence, intermolecular hydrogen bond can exist between the molecules. So, orthophosphoric acid has intermolecular hydrogen bond. Not only orthophosphoric acid, it is H3PO4, orthophosphoric acid. H3BO3, Orthoboric acid it is. Orthoboric acid. Orthoboric acid. It also exhibit intermolecular hydrogen bond. Intermolecular hydrogen bond. So generally this is about intermolecular hydrogen bond. And now I would like to tell you about molecules, associated molecules. Associated molecules. What are associated molecules? The molecules in which intermolecular hydrogen bond is present are called associated molecules. For example, hydrogen fluoride, ammonia, and water, etc. In these, intermolecular hydrogen bond is present, hence these are called associated molecules. Associated liquids mean associated liquids. The liquids in which hydrogen bond is present are called associated liquids. The liquids in which there is no hydrogen bond, they are called normal liquids. They are called normal liquids. Example, CCl4, benzene, bromine, chloroform. In all these non-polar solvents, there is no hydrogen bond is present. Hence, these are called normal liquids. So, this is about hydrogen bond. So, you have to understand the concept and read once and practice the questions. Generally, chelation related examples are frequently asking in competitive examinations such as JEE Main and Advanced and NEET. Thank you so much.